Imagine a country where farms stretch farther than the eye can see, yet very few people actually work on them. This is the strange reality of Australia. The largest farm on Earth is found here, covering more than 2.3 million hectares. That single farm is bigger than entire countries like Israel. Even more surprising, it can run with fewer than 10 people. At first, this sounds impossible. How can so little labor manage so much land? The mystery grows deeper when we look at the nation as a whole. Only about 2% of Australia's population works in agriculture. In many countries, farming employs a large part of the population, especially in rural areas. But in Australia, most people live in cities along the coast, far away from farms. Yet this same country controls over 1 billion acres of agricultural land and supplies food to markets all over the world. Australia is not just farming for itself. It stands as one of the strongest agricultural exporters in the Southern Hemisphere. Its products compete directly with giants like the United States and Brazil. Beef, wool, grains, wine, cotton, and nuts flow out of Australia to global markets every year. This creates a powerful question. How did a country with so few farmers turn farming into such a massive and efficient system? The answer is not luck and not simple hard work. It is a carefully built system shaped by geography, climate, scale, and technology. To understand how this paradox exists, we must first look at the land itself. Before Australia became an agricultural force, it faced problems that seemed impossible to overcome. Long before modern machines and satellites entered the picture, Australia's land stood as one of the hardest places on Earth to farm. Around 70% of the continent lies in arid or semi-arid zones. In these regions, the sun does more than shine. It beats down relentlessly, baking the soil until it becomes dry, hard, and cracked. Growing crops or raising animals in such conditions is never easy. Australia's soil presents another major challenge. It is among the oldest soil on the planet. For millions of years, there has been little volcanic activity and no major glacial movement to refresh the land with new minerals. Unlike the rich black soils of Europe or North America, Australian soil is naturally low in nutrients. This makes it difficult for plants to grow strong without careful management. Water, the most important ingredient for farming, is also scarce. Although Australia is surrounded by oceans, fresh water is limited. Rainfall does not fall evenly across the continent. About 80% of rain is concentrated along the northern and southeastern coastal areas. These are also the regions where most people live. Meanwhile, the vast interior, where large farms operate, remains dry for most of the year. Rivers are few, and long droughts are common. In many inland regions, farming must survive months without meaningful rain. Heat waves regularly push temperatures above 40 degrees Celsius. Under these conditions, traditional farming methods simply do not work. Fighting nature head-on would only lead to failure. Yet instead of giving up, Australian farmers adapted. They learned not to resist the land, but to work with it. This mindset would later become the foundation of Australia's agricultural success. And nowhere is this strategy clearer than in the country's cattle industry. In Australia's harsh environment, success does not come from small-scale farming. The key lies in scale. Rather than trying to make limited land produce more than it can handle, Australian farmers expanded outward. This led to the creation of massive cattle stations, some covering areas as large as 1 million hectares. Australia now manages more than 24 million head of cattle, making it the second largest beef exporter in the world, behind only Brazil. Even a cattle station considered small by Australian standards can stretch across hundreds of hectares. To understand this size, imagine land large enough to hold more than 50 Michigan stadiums. That is normal in Australia. To survive the extreme heat, farmers do not raise delicate cattle breeds. Instead, they rely on tough, heat-tolerant animals like Brahman cattle and strong crossbreeds such as Brahman and Bradford. These animals are built for survival. They can walk dozens of kilometers each day, endure temperatures above 40 degrees Celsius, and resist parasites that would weaken other breeds. They are able to turn dry grasses into valuable protein. More than 90% of Australia's beef farms operate under a semi-free-range grazing system. Cattle roam freely across wide open land, grazing on natural pastures. This movement helps them develop strong immune systems from an early age. Only near the final stage before market are grains introduced to improve meat quality, tenderness, and marbling. Managing cattle across such enormous land areas cannot be done by people alone. This is where technology enters the system. Satellites are used to monitor pasture conditions from space. Helicopters are deployed to gather tens of thousands of cattle and guide them to central locations within hours. What once would have taken weeks of labor can now be done in a single day. The result of this system is beef that reflects the land it comes from. Australian beef is known for being lean, rich in omega-3, and full of natural flavor. Each year, Australia exports more than 1 million tons of beef, generating around $10 billion. Buyers are willing to pay more for this beef, not because it is cheap, but because it represents quality, efficiency, and harmony with nature. And this approach of working with the land rather than against it does not stop with cattle. It continues across other industries that shape Australia's agricultural dominance. Leaving behind the vast cattle stations, Australia's agricultural story continues with another animal that has shaped the nation's global identity: sheep. Across the southeast and southwest of the country, more than 24,000 farms operate a system that does far more than raise livestock. Australia does not simply produce wool. It runs a massive natural fiber empire. These regions offer conditions very different from the scorching north. The climate here is temperate and dry, which is ideal for protecting wool from moisture and mold. This environment allows merino sheep, the backbone of Australia's wool industry, to thrive. Each sheep functions like a living fiber factory, quietly converting grass into one of the world's most valuable natural materials. At around 6 to 8 months of age, sheep undergo their first shearing. This moment marks their maturity. From that point forward, the fleece is harvested once every year. The process is highly organized and carefully controlled. Skilled workers use electric clippers designed to remove the fleece efficiently without harming the animal. An experienced shearer can shear more than 200 sheep in a single day, removing up to 5 kilograms of wool from each one. Animal welfare remains central to the process. If a minor cut occurs during shearing, antiseptic powder is applied immediately to stop bleeding and prevent infection. This ensures the sheep remains healthy and stress-free. Once collected, the wool is tightly baled and prepared for global export. After leaving Australia, the wool travels to high-end textile mills in countries like Italy and Japan. There, it is washed, carded, and transformed into ultrafine fabrics. These fabrics are breathable and naturally regulate temperature, keeping the wearer warm in cold conditions and cool in heat. Unlike synthetic fibers, merino wool breaks down naturally. Within just 12 months, it can decompose into the soil and become fertilizer. This natural advantage has made Australian wool a top choice for global brands focused on sustainability. With up to 80% of the world's fine wool supply coming from Australia, the country stands as the undisputed leader in this field. While livestock covers vast areas of Australia, the country's biggest moneymakers often come from crops that occupy less than 5% of the land. These million-dollar fields generate more than half of Australia's agricultural revenue, officially surpassing livestock as the nation's top income source. One of the most valuable crops is almonds, grown mainly in the Murray-Darling Basin. From February to April, almond trees reach peak maturity. As temperatures begin to ease, the almond hulls naturally split open, signaling the perfect moment for harvest. Timing is critical. A sudden rain can cause mold, while extreme heat can damage the kernels. To remove all chance and uncertainty, the entire harvesting process is fully mechanized. Self-propelled shakers grip the trees and vibrate them for just a few seconds. Ripe almonds fall onto the ground, where they are left to dry naturally. The region's sun and wind reduce moisture levels from around 25% to below the 6% standard in about 10 days. Once dried, sweepers and harvesters move through the rows. Powerful airflows lift the almonds while keeping their shells intact. Built-in centrifugal filters remove stones, twigs, and debris directly in the field. This allows Australia to produce more than 100,000 tons of almonds each year with remarkable consistency. Australia also benefits from timing. almonds are harvested counter-season to the northern hemisphere. When almonds from California have been stored for months, Australian almonds arrive fresh. This gives Australia a strong advantage in global markets, allowing it to compete on freshness rather than sheer volume. Wine grapes follow a similar pattern of precision and adaptation. With more than 2,000 wineries producing over 1 billion liters of wine annually, Australia holds a firm position among the world's top wine producers. Hot and dry climates favor heat-tolerant grape varieties like Shiraz and adaptable whites like Chardonnay. These grapes thrive where others struggle, turning harsh sunlight into bold flavors and strong structure. Further north, Australia's cotton industry operates with the intensity of an industrial plant. During harvest season, human labor is almost entirely replaced by massive machines. These are not simple harvesters. They are mobile processing units. Rotating spindle systems fitted with fine steel barbs gently pull cotton fibers from the plant. Impurities are removed immediately. Once the storage chamber fills, an onboard hydraulic system compresses the cotton into round modules weighing over 2 tons. These modules are wrapped in protective plastic to preserve fiber quality against weather and moisture. Timing remains critical. Each module must reach a processing facility within 24 hours to prevent deterioration. Inside the mills, high-speed saws and powerful airflows separate seeds, clean fibers, and remove dust. The result is cotton with uniform length, high whiteness, and exceptional durability. Australian cotton is stronger and more absorbent than many synthetic alternatives, making it highly valuable to luxury fashion brands. In Australia's vast grain belt, wheat tells a similar story of efficiency. Rainfall here can drop below 300 millimeters per year, yet wheat thrives due to specially bred varieties with deep root systems. These roots extract every possible drop of moisture from the soil. When harvest season arrives, stretching from August through January, the heat becomes an advantage. Wheat dries naturally in the field, reaching ideal moisture levels without expensive industrial drying. This lowers costs and boosts competitiveness. Across endless fields, fleets of combine harvesters work in constant motion. Each machine uses sensors to measure protein content and classify grain quality in real time. GPS systems guide harvesters with precision, allowing them to unload grain into trucks without stopping. Operations continue day and night in a race against incoming storms. While Australia's story shows how scale and machines overcome harsh land, another dry nation faced a different challenge: water scarcity. Israel, surrounded by desert and limited rainfall, needed a solution beyond natural resources. Instead of depending on rain, Israel turned to the sea. Large desalination plants extract fresh water from the Mediterranean using reverse osmosis. Seawater is pushed through ultrafine membranes under high pressure, separating salt from pure water. Energy recovery systems reuse pressure from waste streams, reducing electricity use by up to 40%. As a result, desalinated water now supplies around 80% of Israel's domestic needs at a cost of less than $1 per cubic meter. But desalinated water is expensive to transport, so it is mainly used for cities. To support agriculture, Israel focused on wastewater. Up to 90% of wastewater is treated and reused. At treatment plants, bacteria break down pollutants. Filtration and centrifuges remove solids. The water then passes through soil aquifer treatment, filtering naturally through sand layers deep underground. This regenerated water reaches purity levels close to drinking water and sustains over 60% of agricultural land, especially in the Negev desert. Combined with advanced irrigation systems, this approach allows farming to continue where rainfall alone could never support it. And this mastery of water becomes the foundation for even more precise control over crops and environments as the story continues. Water alone does not guarantee success in farming. How that water is used matters just as much. For centuries, farmers in dry regions relied on heavy labor to pull water from wells and spread it by hand. Much of that effort was wasted, as water quickly evaporated under the hot sun. In Israel, this problem pushed farmers and engineers to rethink irrigation completely. The answer came through drip irrigation. While the basic idea existed before, Israel was the first country to turn it into a reliable, large-scale system that could work across open fields and inside sealed greenhouses. Water is first filtered, then pushed through the main pipelines. From there, it flows into smaller lines laid carefully along planting rows. Along each line, drip emitters are placed about 40 to 60 centimeters apart. These emitters deliver water directly to the root zone, exactly where plants need it most. Instead of soaking the entire field, each drop is targeted. This prevents waste and keeps soil surfaces dry. Leaves remain untouched by water, which reduces disease and evaporation losses. Pressure regulators and automated controllers manage flow rates and timing. Farmers can decide when and how much water each crop receives. This level of control transforms irrigation from a simple watering task into a precision management system. Even in mushroom farms, where plants have no traditional roots, drip systems regulate humidity with extreme accuracy. Here, irrigation controls the environment itself, guiding microbial growth. This technology allows crops to grow in places once thought impossible. It sets the stage for turning extreme heat and harsh conditions into advantages rather than limitations. In the Jordan Valley, the lowest place on Earth, temperatures often climb to 45 degrees Celsius. The soil is salty, the air is dry, and most crops cannot survive. Yet in this harsh environment, one crop thrives better than anywhere else: the medjool date. Extreme heat pushes date palms to accumulate intense sugars. Salty soils naturally reduce pests, allowing dates to grow clean without chemical protection. But producing export-quality dates requires precise control. Each mature date palm needs about 700 liters of water per day in peak summer. This water is delivered through intelligent drip irrigation systems that feed the roots without increasing surface moisture. As harvest season approaches from August to October, timing becomes critical. Date clusters do not ripen evenly. Each bunch is monitored closely and cut by hand at the exact moment sugar levels peak. After cutting, the fruit is carefully lowered to prevent damage. Once harvested, the clock starts ticking. Within 6 hours, the dates must reach processing facilities. Controlled cooling and drying lock in texture and sweetness. This precision produces dates with a soft, rich, toffee-like quality that global markets demand. With yields reaching 120 kilograms per tree, Israel doubles the productivity of many other regions. The same precision appears in greenhouse tomatoes. While a normal tomato plant may yield just a few dozen fruits, Israeli systems push production to nearly 400 tomatoes per plant. Roots grow in sterile hydroponic substrates, isolated from desert soil and protected from dangerous viruses. Drip irrigation delivers exact water and nutrient mixes, boosting sweetness and shine. Pollination is handled by bumblebees, which work efficiently in sealed greenhouses. After about 100 days, tomatoes reach peak color and gloss. Harvesting is done by hand to protect delicate skins. Over 80% of production is exported to markets with strict quality rules, proving that even deserts can deliver premium produce. As labor shortages grow worldwide, technology steps in to fill the gap. In Israel, artificial intelligence is moving farming into a new era. Autonomous apple harvesting robots now work in orchards. Using computer vision, they scan trees, judge ripeness, and detect tiny blemishes before picking fruit. Soft clamps and vacuum grippers remove apples without damage. These robots work day and night under LED lights, cutting labor costs by up to 50% while improving consistency and speed. Orchards begin to operate like intelligent factories, guided by data rather than guesswork. Beyond land farming, technology reshapes aquaculture as well. In shrimp ponds across Asia, the biggest problem lies at the bottom, where oxygen levels are lowest. Traditional paddle wheels only stir surface water. Pure oxygen systems solve this by injecting compressed microbubbles directly into pond bottoms. Shrimp breathe better, escape toxic zones, and grow stronger. Survival rates increase by about 20%, transforming farm profitability. Structural design evolves too. Circular cages distribute stress evenly, resisting waves and currents better than square cages. These systems show how engineering solves biological limits.